Topic 3.2. We want to find a line that contains 4, 1, and that'll be perpendicular to the line x plus y equals negative 18. Now I want to draw this situation so you can kind of see it visually, and then we'll answer it mathematically or algebraically. Okay, now this is in general form. I want to convert this into slope-intercept form, so let's solve for y by subtracting x from both sides, and we get y equals negative x minus 18. Okay, now this is a graph. It looks something like this. 4, 1, which is x is 4, y is 1. 4, 1 is just about there. Y equals negative x minus 18 is somewhere down here. So I can get a good drawing. Okay. So, when they say 4, 1 and the equation x plus y equals negative 18, this is what they're saying. The point is just about there, and the line is just about there. What we're looking for is a line that's going to be perpendicular to this one and go through 4, 1. So what that will look like is a line that goes here that hits it at a perfect 90-degree angle. So we're looking for the equation of this line right here in red. So to find that line, we pull out y minus y1 equals m, x minus x1. And we need a point and a slope. Right now, the slope of the original line is right here. We get negative 1. So the question is, what is the slope that we actually need for our second line? Well, perpendicular means you need to take the additive inverse and take the reciprocal. Additive inverse changes this to a positive 1, and the reciprocal turns it into 1 over 1. So what we actually get is 1 as the perpendicular slope. So let's put that in there. All right, let's go with red. So the opposite of y, right here, will be negative 1. The slope will be 1. And the opposite of x, which is right here, will be negative 4. So negative 1, y minus 1 equals x minus 4. From here I'm going to add 1 to both sides. And we end up with the equation y equals x minus 3. This is the equation of that red line right there. Okay. All right, number 6. Same idea. We want to find this. Let's look at it visually. But this is one of our special lines. This is a horizontal line. Y, when there's a single y, no x's, those are horizontal lines. We have a point negative 3, 7. Negative 3, 7 is just about in this area right here. And y equals negative 2 is going to be a horizontal line along right there. Right where y equals negative 2 right there. Now what we're looking for is a line that's going to go through negative 3, 7, and that's going to hit this line perpendicular, or at a perfect 90-degree angle. So the line that we're looking for looks just like this. Now, this line going up and down, that's a vertical. Verticals are special lines. Verticals are always described as x equals. Okay? And what would the x equal for this up and down line? Well, we know it goes through the point negative 3, 7, and x is the point here that has to go through, so it's all along x equals negative 3. And this is finished. That's the line we're looking for. Next one, we want a line that contains 5, negative 4, but is also parallel to x equals negative 4. Let's draw that situation. Okay. 5, negative 4 is somewhere around this area right here. 5, negative 4. And x equals negative 4. X alone is a special line. Those are verticals. So we'll go to the x-axis, go to 4, and make a vertical line. So we need a line that's going to be parallel to this one right here, but it has to go through the point 5, negative 4. Such a line would look like this. This line would be parallel to the blue one, but it also goes through 5, negative 4. That line we just created is a vertical line. That's a special line, and all vertical lines are represented with x equals. Now x equals what? Well, since we're going through this point, and that point has x is 5, we have x is 5 as a solution. And that's the equation of that red line. Next, we'll be making piecewise graphs. Or piecewise basically contains more than one equation. These are 3 equations that we're going to have to graph. And these are what we call domain restrictions. Domain restrictions. And what domain restrictions basically tell us is where to start and where to stop. So this graph right here, from the left, will go forever. But to the right, it's going to stop at x equals negative 4. This graph is going to start at x is negative 4 and stop at x is 3. This graph right here is going to start at x is 3, but keep going and never stop to the right. So let's separate these and draw these. So we have y equals 2 minus x, y equals x minus 2, and y equals negative 1. Okay, so let's draw all 3 of these situations. Let's put a graph here. Okay, for this right here, I'm going to turn this around and make this y equals negative x plus 2. And here you can see that the y-intercept is going to be 0, 2, right there. And the slope is going to be negative 1 over 1, which means it's going to run 1 and go down 1, run 1 and go down 1. And there's the graph, okay, for this one. Okay. Furthermore, this graph right here is going to, let's see, have a y-intercept of 0, negative 2, which is right about here. And the slope is going to be 1 over 1, which is rise 1, run 1, rise 1, run 1. So that graph is going to look like this. Okay. And lastly, we have y equals negative 1. That's a special graph. That's going to be a horizontal line. So that's going to look like this. Okay. Now, that's a lot of drawing. But what I'm going to do is concentrate on when do these lines start and when they stop. Let's do the red one first. This one right here, according to this, stops when x is negative 4. So let's put in x is negative 4, x is negative 4, and we get y equals negative 4 plus 2, which is y equals 4 plus 2, and y equals 8, which means that's the point, x is negative 4, y is 8. So the red graph stops right here with x is negative 4 at this point right here. That point is going to be, because there's a bracket here, closed. And that's going to stop right at negative 4 and 8. So let's draw that again and just stop it, closed circle, at negative 4, 8. Okay, this graph right here is going to start at x is negative 4 and stop at x is 3. So it's going to start here at x is 4 and it's going to stop here at x is 3. So we have to put negative 4 and 3 inside there to get our 2 starting and stopping points. See, I'm out of room, so I'm going to erase this. And let's see. When x equals negative 4, we get y equals negative 4 minus 2, which is negative 6. That, let me push this over a little bit. That gives us our starting point of x is negative 4 and y is negative 6. Okay, so that's right about here. And that's going to be open circle because we have a parentheses here. So So that's negative 4 comma negative 6. That's the starting point. Negative 4 comma negative 6. And it's going to keep going until we get to x is 3. So we'll say x is 3. And that's going to give us y equals 3 minus 2, which equals 1, which gives us the point 3 comma 1. 3 comma 1 stops just about here. And there's a bracket, so there's going to be a solid there. So that's my 3 comma 1. Let's draw it here. A little solid. 3 comma 1. And finally, this line right here starts at x equals 3. This starts at x equals 3. So if I start at x equals 3, and my line is y equals negative 1, my starting point will be 3, negative 1. So right here, and it'll be open because there's a parenthesis there, open at 3, negative 1. So I'll put an open here, and then keep going to the right forever, infinity. And that point is 3, negative 1. And this is my piecewise graph with the 3 pieces, and they're all labeled.